Alright, the last part of this section, so it's calculator. Find a power model. Same thing as when we found the exponential model, because they give us a table here. It talks about the typical windspans and the typical weights of these birds. So it says 1, draw a scatter plot in the data pairs. Can't talk right now. And what is a good power model that fits this data right here? And it says find. This is the key. Find the power model for this original data right here. Here's your X's. Here's your Y's. And this question right here, once again, I'm not going to make you do stuff like this. Draw a scatter plot, data pairs. This is just trying to show you a relationship. If there's a power model, like I told you, kind of looks like this. If you plot these points, it probably looks something like this. And then, but if you plotted points, natural log of this one, comma, natural log of this one, ln y, and you plotted all of these ln x, ln y, ln x, ln y, it would actually make a straight line again. So there's a relationship here they wanted you to see, but I don't feel the need to kind of go through all of that. Just wanted to show you about it, tell you about it. Here we go. How do we find the power model for this data right here? All we got to do is put it in the calculator. So I already did that to kind of save time on this video. So here's my data. I put it in L1, L2. Remember, go to Stat, Edit, L1, L2. So put in those values. Once you're done putting in those values, then we go to Stat again. Stat. We go over to Calc, just like we did before. And we keep scrolling down until we find the right one. There it is. We did exponential regression, now we do power regression because it said it's a power function. So, power regression. That means the best fit power model. Here we go, hit it. Enter. Since I use list 1, list 2, I just have to enter. Remember, I told you before, if you use list 3, list 4, do that. L3, comma, L4, and then hit enter. So, hit enter. Here we go. Here's our power model. 0.044 and 2.87. 0.044, 2.87. So we're going to use that right. Forgot. 0.044, 2.87. Right here. So we found A equals 0.044, and it told us B equals 2.87, I think. All you have to do is know the right model. Power model, y equals A times x to the b, not the other way around, remember. So put in A and B right here. So it becomes y equals A is 0.044 times x to the b power, which is 2.87. This is the power model that represents this original data right here. Just got to pick the right one. Exponential or power. It tells you. Alright? I'm not going to make you figure it out by yourself. Okay, last example, example 6. We're going to use our power regression. We just found our power regression to be y equals 0.044 x to the 2.87. It says use it to estimate the weight of a bird with a wingspan of 4.5 feet. So the wingspan was x. Alright, so here's your wingspan, and then y was the weight. So they're telling you wingspan of 4.5, so put 4.5 right here. So y equals 0.044 times x is 4.5 feet to the 2.87 power. Since it's all here, all you gotta do is put it in the calculator, hit enter, and you get y equals what? Should get 3.31, about 3.31, close to that. I rounded up here, so it might be a little bit off, but 3.31. It says weight, so I think it's in pounds. There you go. This is how you predict. So that's what we use these regressions for, to predict things. That's it. That's the end of section 7, which means the end of chapter 7. Make sure you study. Make sure you come to class with good discussion. Okay?